Hello everybody. Let's quickly solve a geometry question. Okay. What we're given is a rectangle OAPB. We're given a diagonal, one of the diagonals OP, and we're given a line RS parallel to OA, which intersects the given diagonal at the point Q. We're also given that the length of QR is 7 units and the area of triangle OQS is 84, and using this information we need to find the length of BQ, the red one. Okay, all right, now to solve this, let's say the length of OA is A, okay, and the length of OB, the entire length OB is B, okay. Then the coordinates of A are A comma 0, the coordinates of B are 0 comma B, and therefore the coordinates of uh, coordinates of P are A comma B. Okay, A comma B. So what we can do, we can find the equation of the line OP as y equals mx. The slope of this line is b over a since it passes through the origin. So the length of the equation of OP, is y equals b over a x. All right, b over a x. Then what else can we do? We know that this length is 7. Let us suppose that this length is k. All right, this length is k. Then, since this is a rectangle, OASR is a rectangle, or ORSA is a rectangle, we can say that OA is equal to RS, and therefore RS is equal to A. But RQ itself is 7, so this length is A minus 7. Okay, and since this entire length is B and a part of it is K, the remaining part, that is BR, is B minus K. Since BRSP is itself a rectangle, and BR is equal to, BR is equal to, okay, BR is equal to, BR is equal to PS, we can say that PS is also equal to B minus K. Okay, all right. Now, let's look at the point Q. The point Q has the coordinates, let's say, let's drop a perpendicular. Obviously, I'm taking the x-axis along OA, positive x-axis along OA, and the positive y-axis along OB, which is clear by now. Let's see. This is 7 and this is K. So the coordinates of the point Q is 7 comma K. And since it is 7 comma K, since Q is a point on the line OP, it must satisfy this equation. So what do we get? X equals 7. So 7 times K. Okay? 7 times K. So from here, we can say 7 over K over 7, or you can say 7 over K equals A over B. That's okay, but let me just not mess with B's and A's. Let's just use the constants. Let's just do it like this. Okay. Now, let's see, why did we get this? Since Q lies on P. Since Q lies on P, we have this result. Alright, okay, just okay. Alright, he's done with his barking now. Okay, K over 7 is equal to B over A. Now, let's see, B over A. B over A. B over A is the slope of OP. Okay, slope of OP. Next, B minus K over A minus 7. B minus K over A minus 7. This is also y2 minus y1, x2 minus x1 is again the slope of OP. So from here, what do we get? B over A equals B minus K over A minus 7. Okay? And from first equation and second equation, what do we get? K over 7 equals B minus K over A minus 7. Alright, now this gives A minus 7 times K equals 7 times B minus K. Okay, now I don't think I had to use this B minus K, so I'm gonna erase it. Now let's see. We know that triangle OQS has an area of 84 units. So this is half times A minus 7 times K. Alright, so A minus 7 times K is equal to 84 times 2 means 168. Alright, 168. So 7 times B minus K is equal to A minus 7 times K means 168. So this is 168. I guess it was better like this because I can cancel out the 12, the factor of 7 with 84. 12 times 2 will mean that B minus K is equal to 24. Okay, B minus K is equal to 24. So this is equal to 24. So to find the length of BQ, we can use the Pythagoras theorem, 7 squared plus 24 squared inside of the square root, which will give us a length of 25. So this is how we solve it. Okay, this is one way to solve this, but I've got an easier way to solve. So let me just clear the board for now. We're using the same notations as we have used before. What do we get? We get something like this. Now if I say that this angle is theta, then this angle will also be theta because the sides of the rectangle are parallel. Opposite sides of rectangle are parallel. Next, as before, this length will be B minus K and this length will also be B minus K. Okay, now let's look at triangle PQS, and from that triangle we get tan theta equals A over 7 over B minus K. Okay, and if we look at triangle ORQ or OQR, we're going to get tan theta equals 7 times 7 over K. Now from the last two equations, we're going to get k times a minus 7 equals 7 times b minus k. And as before, half a minus k times a minus 7 times k will be equal to 84. So this part will be equal to 84 times 2. 84 times 2. And so we can cancel out a factor of 7, which will give us b minus k to be equal to 24. Now, since the required length is 7 squared plus b minus squared under root, this will be equal to 7 squared plus 24 squared, which is equal to 25. As simple as that. Okay? These are the two ways to solve it. And I could have discussed the shorter way earlier, but what happened was I was trying to solve this question using the first method I just discussed, and after I solved it successfully, I tried to look inside the rectangle to find something that would make things easier, and it did. So I found the second solution after my first solution. Okay, after completing my first solution, I searched for a simple solution, and the solution was inside of the first solution, and this is the solution. Okay. All right. Thank you very much for watching, and yeah, that's all for today.